pleasure to welcome one such star, Dr. Netrananda Sahu in Gyaan lecture series, our today's honorable guest. I also welcome Honorable HOD Ma'am, Madam Rekha Acharya, our coordinator, Sir Samraat Acharya, and respected Sohail Sir. Devi Ahilya Vishwavidyalaya is one of the renowned institutions of Madhya Pradesh, established in 1964, have an aggregate of A plus grade by NAC. The ideal foundation of Devi Ahilya Vishwavidyalaya is planted at the sapling and now is grown as a large fruitful tree. Here we could see the blend of extraordinary teachers and professors working 24 into 7 to uplift and to bring university at the high position. Dr. Netranand Sahu, sir, we celebrate your leadership and you keep influencing us. By this note, I would like to share some information about our respected chief guest. Dr. Sahu is Assistant Professor in Department of Geography, Delhi School of Economics, Delhi University. Dr. Sahu has completed his post-graduation from Department of Geography, Delhi University in 2004. Sir has completed his MPhil from Department of East Asian Studies from the University of Delhi in 2008. Then PhD from the Department of Urban and Environmental Engineering from Kyoto University in 2012. Some of Sir's other achievements like JSPS postgraduate fellowship at DPRI Kyoto University by the government of Japan from 2018 to 2020. Max scholarship by government of Japan for PhD Young Researcher Award in Kyoto University in 2012. Again Young Research Award in next year in Kyoto University, and so many publications as well as so many achievements which cannot be discussed at a time. It's an honor for me to open today's Gyan series. It's a blessing for us that such an extraordinary lecture series is organized by Devi Ahilya Vishwavidyalaya. I would like to extend gratitude on the behalf of all the children, all the students who are attending this series, to our respected head of the department, Madam Rekha Acharya, our associate coordinator, Sir Samraat Acharya, and Sohail Sir, that due to their hard work and uh, due to their hard work, they arrange such kind of wonderful series for us. Thank you so much. I request our Honorable HOD ma'am to welcome our chief guest.
Thank you, Khiza. First of all, good morning to one and all present here, particularly the guest of the today, Professor Netranand Sahu, Department of Geography, Delhi School of Economics, New Delhi. On behalf of the School of Social Sciences, Devi Ahilya University, I welcome you, sir, in this guest lecture series known as Gyaan. Today is the sixth lecture, and we are very pleased that you have accepted our invitation and so kind that you accepted and readily uh, mm, accepted our invitation for delivering this wonderful lecture on ocean geography. And this particular area is obviously new for the students of geography belonging to Madhya Pradesh, because Madhya Pradesh is a center part and sea is far away. So ocean geography is one of the very new area which our students would be certainly going to benefit by the expert knowledge of you. And sir, we are really very pleased that people like you and experts like you, they give their consent to deliver lectures. Let me briefly explain about my department, that is School of Social Sciences, although initiated in 2008 in the name of the School of Social Sciences with the courses of PhD and MPhil. And in 2014, we have initiated MSW and BSW. And since 2018, we have introduced some MA programs, sociology, clinical psychology, and political science. And apart from the MBA in public administration and rural development. And past 2 years in 2018, we have thought of introducing our BA programs. So initially, we have basically given two specialization along with common subjects of history and political science, sociology and psychology as a third subject in the name of specialization. And this year we have introduced, looking to the heavy demand of the students, this year we have introduced geography as a more specialization. We are having planning to organize such courses as integrated courses for 5 years, so that the same students can continue and have their specialization in their post graduations. Our course structure is basically designed according to the UPSC and catering the needs of the PSC. So, sir, such kind of your lecture on ocean geography will certainly going to help our students and enlighten their knowledge. On behalf of the School of Social Sciences, I once again welcome you and extend my sincere thanks to you. Thank you, sir.
Thank you, madam. Thank you, madam, Principal Professor Rekha Acharya, for inviting me, and to all the students, good morning. So I think today you will enjoy the class. I mean, I will talk about the oceanography, basic things, and then later part, because it's two parts. So in the two parts, first part I will deal with the oceanotopography and all these features and oceans and normal terminology, and then I will deal with the second part more like dynamics on it, like ocean dynamics and currents. So thank you, Devi, Ahilya institutions for inviting me, and School of Social Science, and particularly Principal Professor Rekha Acharya, and thank you Kijar Khan for introducing me. Okay, so now we can start with the class for my lecture, because I think introduction is enough. I think it's not that required, but anyway, so let's go for the class. Okay, I will share the PPT. I think that will be better, because all of you are undergraduates, I think. Otherwise, normally also sometimes in the higher studies, I usually speak without using PPT, but here to look the visual and audio visual, both things will be good. And also for the undergraduates, more things will be clear if you will see what is there. We are going to deal with the class. So all these things will be very clear if there is a PPT, or in the PPT also I will explain in detail like what are the lectures consist of. And sometimes I think before going to start the lecture, formal lecture, I would like to ask if because my Hindi is not that good, and the भौगोलिक शब्दावली जो बोलते हैं हिंदी में, ये थोड़ा सा मुझे कमजोर है, क्योंकि मैं उड़ीसा से हूँ और हिंदी मैंने यहीं दिल्ली में आने के बाद ही सीखा. सो मे बी मेरा जो हिंदी है इतना सही नहीं है, ग्रामेटिकल बोल सकते हैं, जैसे भी हो थोड़ा गलत हो सकता है. तो इसलिए I mean I will try to speak in English, and if you have any problem, please let me know, so that I will explain in Hindi, whatever Hindi I can. I mean, so is that okay?
Yes, sir. Don't worry. Yes, our students can able to understand English as well as Hindi both.
Okay, okay, then it's good. Okay. So now I am going to present the PPT. So just opening the PPT, I will share the screen. Just wait for a minute. Can you see? Is it visible to all of you?
Yes, sir. Yes, sir.
Yes, sir.
Yeah, okay.
Yes, sir, visible.
Okay, introduction to oceanography. I think when we are talking about the oceanography, like ocean particularly, so that means in your mind it comes the water, okay? Because everywhere in the, like we have two hemispheres. If you see northern and southern hemispheres, and if you see the pictures of northern and southern hemispheres, you will find one hemisphere is mostly on the land mass, and another hemisphere is they're mostly in the ocean. So when we're talking about the ocean, what is ocean? Well, like how many, I mean, there are how many oceans, And what is the role of oceans for any socio-economic climate conditions? So what is the role of oceans? That we are going to study today. Also, with that, we will also know about some features, shape, size, different types of characteristics of the oceans, and what are the ocean topography, and within the ocean topography, like starting from the continent, ocean, then deep ocean, so like continental margin, shelf, slope, continental rise, and abyssal plains, and deep sea plains. So we have many things we will know on the topography of the ocean. Along with the topography, the more interesting and dynamic features is the ocean dynamics. That means what is the ocean, the role playing by the ocean. Ocean influence the global climate. Ocean influence the climate variability. Ocean influence our day to day in a certain way, like whether in a particular area there is a drought, or like it's a rainy, more dry conditions, wet conditions, or all over the climate parameters also many times are influenced by the ocean warming and cooling. So like because of ocean warming and cooling, we have the global phenomena or climate variability that develops, and that influence through the zonal wind, and the zonal wind carries these water vapors from the ocean, and all over the globe, entire world, where it is sometimes more rainfall, in some areas very drought. So all these features, all these characteristics, and that depends upon the different types of agriculture, like biodiversity, ecology, and ecosystems. All these things are totally dependent upon the, like also this ocean variability. And not only this plant and animals life systems, but also we have like all different types of disease also nowadays. There are some diseases are also like vector-borne disease, for example, dengue, malaria, and all this type of disease are also influenced by different types of climate variability. Even because of this ocean warming, that influence also the forest fire. So many types of issues that involves with the ocean dynamics, like ocean currents. So with the introductions of the oceans, let's one world ocean. Like if you see this world, we have the oceans. Here we can see the largest ocean, like Pacific Ocean, then Atlantic Ocean, Indian Ocean, Arctic Ocean, and Southern Ocean, which is Antarctica, right? So you can see all this. This is just simply the distribution of these oceans around the globe. And with that, what you the features, basically silent bullet points, if you remember, like the ocean covers 71% of the Earth's surface. Okay, 71% of the Earth's surface covered by oceans, and accounts for greater than and more than 97% of the Earth's water. Okay, so only we have 2.5%. It's 97.5 almost that percentage of water on the ocean, and whatever we are using in the land surface, okay, on the 29% of the land mass, only 2.5% of the water. So you see huge water there in the ocean. The average depth of the ocean is 3,800 meters, that is around 12,500 feet, and at its deepest depth is 7,000 feet, greater than the highest elevation of the Mount Everest. So that means Mariana Trench, which is the deepest part of the ocean, is 36,163 feet. And if we compare that with the landmass highest elevation or highest peak, is the Mount Everest, that is 29,000 feet. So almost 7,000 depths greater in the sea. And the average temperature of the ocean is only 3.9 degrees Celsius. So you see how the land mass and the ocean are distributed. So within a land only 29.2%, which generally it is termed 71 because it is 70.8%. So 71 and it is 29%. But in actual, this is the figure. So within land mass, continental platforms only 18.9%, and the continental mountains are 10.3%. And then other 71% or 70.8 points are land masses like oceans, ocean reaches, then ocean basin floor, and uh, ocean arcs and fjords, trends. This is 3.7%, and then continental rise around 3.8%, and also continental shelves and slopes 11.4%. This is the way the land mass and ocean body has been distributed with a different area it occupies. So if we talk about total water availability on the earth, that is, if salt water is 97.5%, okay, so fresh water is only 2.5%. Whatever water we are consuming, including our irrigation purpose, including rainfall and whatever happening in the land mass, all this water is only 2.5% of total available water. So then you imagine within this 2.5%, we have huge land mass, land populations. They are totally dependent on this 2.5% of the water, and also many times this washing water has been purified and used for different purpose also, but this process is too costly. So some areas which is very necessary, people are also in different countries, they are also using this for other household purposes. So this fresh water is only 2.5%. Within that fresh water, it is like glaciers, then permafrost, then groundwater, and the surface and atmospheric water is 0.4%. Within the surface atmospheric water, then freshwater lakes and all like biota, rivers, wetlands, atmosphere, and soil monsters. You see how the water, then you can see the real picture of water availability. So that's why water is a like water conservation for the huge population is very necessary also. So here when we are talking about the water in the ocean, you see even 97.5% of salt water, how it is going to give different types of because of that huge salt water. This also develops like variability within different temperature fluctuations within the ocean, and that creates different types of weather phenomena. So here you can see the average depth of ocean and comparing the ocean of land. You can see the sea level, Pacific Ocean, Atlantic Ocean, Indian Ocean, and Arctic Ocean. If you can see all this, and here in each ocean, Pacific, Atlantic, Indian, and Arctic, all these depths, highest depth within that ocean has been written here in feet, and also you can see land within landmass also. You can see here the tallest is Mount Everest, and this is the basic feature. Okay. So let's come to the point for one thing. After knowing all this, how, I mean, importance of ocean, let's come to the point like is formally, what is oceanography? So why you need to study oceanography? Okay. As you know, maybe oceanography is the scientific study of Earth's ocean. So what is scientific study within that? Like we have different features within the characteristics of the oceans. So scientific analysis of the ocean, even till today, very little of explorations of the oceans has been possible. There are still huge resources in the oceans are unexplored till today, even if we have advanced technology. And the branch of science that deals with the physical and biological properties and phenomena of the sea, that is oceanography. Okay. Within geography, this oceanography is also another just like sub-discipline, or you can see some universities also there is oceanography is a separate subjects also. Like we have oceanography, a National Institute of Oceanography in Goa also, that is there as a research institute. They are doing research only for the ocean related to oceanography and ocean features. So this oceanography is the branch of science that deals with physical and biological property within the ocean and also the phenomena within the sea. So all these phenomena and physical features we will discuss one by one. See the oceanography and our oceans. 70% of is already I have taught that it is 71% of the Earth's surface is covered with water. So it is important to know something about the water surrounding us. Okay. Even as Madam has told, it is Madhya Pradesh, but we can learn many things from the ocean. Like I'm from Orissa. always, almost every once a year or once in 2 years or 3 years, we have a cyclone. Every time we are facing many difficulties, and also coastal area, erosion of coastal landmass. And from my childhood, the village, I am from coastal belt of Balaswa, and I know also some villages already eroded to the ocean. I know from my district also 3 villages already are submerged in the oceans. So that is another problem, like climate change, sea level rise. But here, let's first finish about the ocean topography and all this. So in the northern hemisphere, 61% is water and 39% is land. You see the left side picture of northern hemisphere and southern hemisphere. Here you can see that, like, southern hemisphere mostly sea and oceans. Okay, so that's why the northern hemisphere with 61% of water and 39% of land, thus it is called as land hemisphere. And the southern hemisphere 81% of water and 90% of land, thus it is called only water hemisphere. You can see, just this is the something which may be a very catchy terms, but it will come to your mind. So how these oceans origin, the origin of oceans. Okay, the earth is believed to be 4.6 billion years old, and during the earth's formation, heavy and dense metals such as iron, nickel gravitate towards the hot center in the molten state. But at the same time, lighter elements such as aluminum, silicon, rose towards the surface, forming the Earth's crust. Okay, this is, the plate tectonics theory. When we are talking about this plate tectonics theory, also sometimes we are dealing with this type of Earth and the crust, how the molten things are coming because of the shifting of different types of continents. But anyway, we know what is the Earth's crust, and within this, when there is a like formation of the origin of the oceans, as you might have known, the Himalaya, once upon a time it was the Red Sea, and that upliftment of that sea still processes continue, and the Himalaya is one of the youngest mountain systems. But here, when we are talking about the origin of the earth, you can see the crust is made up of different types of rocks, and so is the thinner and thicker plates. So thick is land, and thin is ocean. Within that, and when eventually the young earth cold enough such that water vapor condensed and collected in the ocean basins, and as water collected, it dissolved minerals within the rocks. And water and this ocean difference, when the first water, evidence of any first water in the earth and evidence of birth of a ocean is almost 20 million years. There is a gap. So after 20 million years of rain, the oceans were born. It's geological history if you want to remember it. So then we have 5 oceans, like specific, the largest and deepest oceans, and Mariana Trench is almost 11 kilometer depth, and then Atlantic Ocean about only half of the size of the Pacific Ocean. Then Indian Ocean, the southern hemisphere, then like Bay of Bengal, Arabian Sea that joins the Indian Ocean, and this Arctic Ocean is 1/4 as deep and much smaller. This is mostly also sea ice. Okay. Then southern or Antarctica, so side that is southern of 50 degree or south latitude. Okay. Then studying the ocean floor. How you need to study the ocean floor? If just first this class, I will detail about the ocean features. Okay. So why we need to study and how we are studying the ocean floors? It's so much of depth, more than 11 kilometers in Mariana Trench. So how can we study it? What is there in the floor of the ocean? Even it is very difficult, the top of the Everest to reach. So it is very difficult to see. But since it is on the above, we have satellite. We can use satellite, different types of satellite, to know the landmass features. But about the depth, what is beneath the water of the oceans. So that study is very interesting, and that is first way is sonar, then echo sounding, and also use of satellites. So what is sonar? The sonar stands for sound navigation and ranging, and different types of sound propagation. Through sound, scientists send sound waves to the bottom of the oceans by sea, and through that wave propagations, they try to establish what is there within the beneath the water. Uh, so then the sound waves bounce off the ocean floor and return to the sea. And the deeper of the ocean, the longer it takes for the sound waves to return. Okay, this is the process of sonar. Through it, what are there? The one way to study, scientific study of what are there in the floor of the ocean, and it measures the water depth. This is like a sieve, and then it's sends the like a target where you are sending the sounds, and then through echo, and it's coming back. So this process you can measure the depth of the water. Then echo sounding. Shapes can be determined by measuring the time it takes for the sound to bounce back. And some marine life also uses this method of sounding different types of sound systems, echoing. So this is the more clear picture of a echo and sonar systems which are working to measure what are there in the ocean floor and to see different features also. And how the satellites send image to the earth that measures directions and speed of the ocean waves. So to see different types of ocean waves, also using these ocean waves, different types of characteristics and features, you can see whether it is a trends, whether it is a gears, whether it is different features within the earth is very easily now can be sea floor is easily we can read, but what is beneath that? That is still unexplorable, like different types of minerals and resources. Still many unexplored part is there. So the another thing is like CSAT, different types of techniques which are used to understand this now, uh, like different features in the ocean floor. So different types of satellites in the sea also. The CSAT was the first Earth orbiting satellite designed for the remote sensing of the Earth's oceans and had on board the first space-borne synthetic aperture of radar, different types of radar-borne systems. When I was in Kyoto University, and I had seen different types of and how the radar systems are using, and through that image different types of interpretations and all this highly technological devices can be applied so that we can know many things nowadays. But earlier it was very difficult. You see when the different uh, uh, from one place to another place, even discovering different types of island, it took thousands of years because of the ancient periods. That was technology that time that not that advanced. Then another form of satellite is geosat. So used for the military satellites, measures height of the ocean surface, and also different underwater features affect the height of the water above the land. So there are many other ways also to know all these things. So it's basic one or two things I have put here, that how we can study what are there beneath the floor. Then let's talk about the ocean topography. Okay, what are the features within the ocean topography? So oceanographers studying the oceans and ocean floor have found three major parts. Generally, the continental margin, ocean basin floor, and mid-oceanic ridge. Now, within the continental margins, these continental margins refer to the region of transition from the land to the deep sea floor. That is, between the continental and oceanic crusts. In an active continental margin, the boundary between the continent and the ocean is also a tectonic plate boundary. So there is a lot of geological activity around the margin. You see, once continental margin, continent, then continental margin, then it is continental shelf, then continental slope, then continental rise, then deep sea plain or abyssal plain, hills, and many things are there. So when we are seeing the continental margins, after continental margins, it starts with the continental slopes. So when from the continent, from the land mass, when entering the sea, It starts with the continental margin. Then within the continental margin, that is continental shelf, then continental slope. Then from, if somebody will ask, sometimes in the questions are asking sequence, to maintain the sequence from the land to ocean. So what are the features coming first? Like continental margin, within the continental margin, we have continental shelf, slope, continental rise, then abyssal plains, maybe deep sea floors or ocean trends after that. So you can have a sequence, that is a clear-cut sequence. So sometimes this sequence also asked in the very competitive examinations. So you have to remember also the sequence, like continental margin, then continental shelf, slope, and rise. Then I have ocean basin floor. Within the ocean basin floor, I will again discuss all this. What are the ocean basin floor and mid-oceanic ridge. So what is continental shelf? This is a very gentle slope, submerged land. Okay. Then continental slope, steep slope on the edge of the continental shelf. It is very little vertical. It's like, slopey. So then continental rise, the gentle slope where trenches do not exist in the continental rise. So surprisingly, we know very little about the mapping of our ocean floor because of, even if we have radar, sonar, and other techniques, but still only 5%. Probably we have accurately mapped only 5% of the ocean floor. And it is a time-consuming, expensive, and our current technology only allows us to map a few miles at a stretch. So, like taking at a stretch is also not that easy. So because of that, we are also have some sort of difficulties in actual mapping the ocean floor. So then we have, you see here the picture of continental margin. Here you can see coastal area, for example, continental starts. This is coastal area, still it is a continent, then starts continental shelf, slope, continental rise, and then it's the ocean. So this is just a basic feature, and here you can see this is like, uh, where is the continental shelf, starts from the continental margin, then you see where is the slope, then continental rise, then abyssal plain, deep sea plains, and also sea mounts. And there are different pictures and also different, you know, uh, pictures you can see here, a very clear distinction one, how all these features and characteristics of the ocean basin topography you can see starting from continent. If sequence wise you will see starting from the continent, here this picture is very good, very well defined, and all the features even including some trenches, where are the sea mounts, how these abyssal plains are developed, and the geodes, and all these features are there. Okay, so this is another very good feature to describe the ocean floor characteristics. Here you see the mid-oceanic ridge and the rift valley and the trends. Very clear picture of how continental shelf, then continental slope, then it is continental rise, and after that continental it is sea mounts. You can see here. Abyssal plains. Plain is just like more flat area. Okay. After continental rise, it is abyssal plain. It's a very flat area. Then sea mounts and volcanic islands. Also, you can see very 3D picture type. And this mid-oceanic ridge is there. It's a total plate tectonic events that mostly vulnerable part of the ocean. And you can see also globe, because this ridge, mid-oceanic ridge is very fluctuating, like it's a more continental drift theory is happening. So because of that, I mean, its ocean ridge is very vulnerable to this plate tectonic theory and understanding of plate tectonic theory. And this there you can see the trends. You see this Mariana Trench, how depth it is, so 11 kilometers beneath the sea in the Pacific Ocean. And another features on the seafloor also, this is different types of fault, basically to see here how the transform different types of within the mid-oceanic ridge, how different types of faults created within the seafloor also. And the volcanic activity along with the mountain also, the volcanic activity is a more very serious in the mid-oceanic range. And this mid-oceanic range, when there are any volcanic activity, there also creates some tsunami because of this volcanic ascent coming, these earthquakes happening in the mid-ocean, many times that creates tsunami. And when I was also in Japan in 2011, and that was a great earthquake, that great tsunami, so ever recorded in the history of the earth. That was recorded in 2011, okay, in the March 11th to March 2011. That was the day where that very height, as for the height, great tsunami occurred, and this is because of these volcanic activities and earthquakes happens in the ocean, specific oceans. So you see, and another picture also, why I'm used the for picture here to clearly define different features within that. Not only you see the abyssal plants also. If you see from the continent, then continental shelf, slope, and then also some volcanic lands. Sometimes abyss or abyssal plains are also literally called abyssal plants. So these are very within a Atlantic Ocean. See the sea floor, basin floor of Atlantic Ocean. Okay, this is basin floor of Atlantic Ocean. So, what are the features of the ocean floor? Like within the features of ocean floors, continent, shoreline, continental margin, then deep ocean plains, and within deep ocean plains, seamounts, abyssal plain, mid-oceanic ridge, rift valley, volcanic islands, and ocean trench. You see, the continent generally, defined as a landmass and not underwater, and there are 7 continents. And here shoreline, a narrow, gentle, sloping strip of the land that lies along the edge of an ocean. You can say a beach or a coastline. Within that, it is a shoreline. Okay, it's a very narrow one, and sometimes the beaches are very, like, it depends. That's why even if in India there are more than 7, I mean, we are three side we are covered with the water, that means Arabian and Bengal Sea, but still, as for the beach, different types of beach, many beaches are not very good. Only Goa and some very small in Kerala and very small in Orissa, and that beaches are somehow there, but western side the beaches are very, I mean, almost narrow. In Kerala there is only very Kovalam, it's very small because of the western Ghat that creates depth is very high, height is, there's mountainous area, so there is no clear beach. So that is also another like feature of why in the western side of India there is no more beach, because shoreline is not that elongated. That's like it's very deep there. So here you can see this is the picture of shoreline. You can see how to touch the shoreline within that from continent to land. Okay, when we enter from continent to land, that small narrow edge, that is the shoreline, and then continental shelf, the part of continent that extends underwater to the deep ocean floor, and it begins at the shoreline. So, I mean, sometimes the very multiple MCQ type questions are coming. Also, the shoreline begins from the continental slope or rise or continental shelf. So normally the continental, it starts from the continental shelf. It begins from the continental shelf, which is also touching the continental margin. So it's a very it's underwater, but very, I mean, shallow type. It's not very. It's just underwater to the deep ocean floor. It starts from there, continental shelf. So it continues until the ocean floor starts to slope. Okay. This part is continental slope. Then continental slope, sometimes steep descent of a continental shelf to the ocean floor. It begins at the edge of the continental shelf, and it continues down to the flat part of the ocean floor, that is still abyssal plain. Okay, so continental slope starts from the continental shelf and it continues to the flat part, that is abyssal plain of the ocean floor. Okay. Then we have a continental rise, like large piles of sediment at the base of the continental slope. Okay, so that is known as like continental rise. You see, I have shown you the pictures. You have seen all these pictures, but after knowing all this, what is the significance of this study, topographic study, which is basically when in a geomorphology you are studying different types of landforms. Similarly, here we are studying different types of characteristics, features of the within a ocean. Okay, and after knowing all this, you can do different types of research in each and every each part, whether continental margin, whether continental uh, like slope, rise, or every self, every part of that, you can have a different types of research. There's a very large area of, different types of study can be done. Like nowadays, it's a level of sea level rise. It's a very big questions of because of the climate change. So when there is a big questions of sea level rise, which area is affecting more? Including the continental margin, continental shelf, slope, but not the rise part. Mainly continental shelf and that slope starts. So when sea level rise, mostly affected part is the coastal line, which is shoreline and also continental margins. Okay, so that is also very very important. As I can see also in Orissa, in my home districts, many coastal erosions, and also we have different types of landforms because of this ocean or waves in the ocean, that features. Because today now it is only introduction, because it's only 2 class lecture will not sufficient for the total covering of the entire oceanography. So that's why basic features I try to cover in the first part, and when I will go to the second part, I will deal with the detailed descriptions like the ocean currents and basically why we should study about the oceanography or ocean things, how interesting it is. The main interesting factor is the ocean dynamics. That's very clear, logical behind it. But within the ocean resource, natural resource part, and the topography and features and all the shapes and characteristics of the oceans, that is still many areas. Only we know where the trends, what are, how many oceans, and all these areas are still only 5% we are still known, but there are many 95% around we didn't have that any information about the ocean. So as for the NASA observatory, if you can visit, also you can see like from the website also you can see only ocean part. You will try to understand how there are many areas still unexplored. So you have, if as a geography students, you will be in near future, you will start your career in oceanography. It will be very encouraging subjects. You can go, you can do your research on that. And when I was my PhD, so I started also taking a challenge on the ocean dynamics, features of ocean dynamics, not on ocean explorations or maybe natural resources beneath the ocean. So within this, if you want to study, you can make a career. It's very many unexplored area is there. So then it comes about the deep ocean basin. Within the deep ocean basin consists of sea mounts, abyssal plain, mid-oceanic ridges, rift valleys, volcanic islands, and ocean plains. So what is sea mounts? Underwater mountains made of volcanic material. Okay, when volcanic activities happens within the sea, that creates a mountain features. Like in the landmass, we have volcanic mountain, Mount Fuji, also Etna in Italy, Mount Fuji in Japan. These are volcanic mountains. I have tracked Mount Fuji in Japan. So these are volcanic mountains. You see in the land features, land mass, it is very easy to see, oh, this is a volcanic mountain. So in the sea, deep ocean, this mountain like volcanic activity when forms, and then it also deposits a very a large mass of sediments and magma, and then after cooling within the oceans, it also becomes like a mountain area. So this is sea mounts, the mountain in the sea. So it formed when magma pushes its way through or between the tectonic plates. Okay, and if sea mounts build up, they can become volcanic islands. Examples are Hawaiian Islands, Alaska, Brazil. Okay, and also sea mounts are usually 25 miles or 40 kilometers in diameter and can be of it varies also from 3,000 to 4,000 meters tall. Okay, varies different types of sea mounts. Okay, within different oceans. Also, all the oceans we have that type of sea mounts. Less than 0.1% of the world's sea mounts have been explored to learn what species live on them, but many of the species that have been found so far are new to the science, totally new. Mm. Just yesterday I was in a seminar where the editor of the Nature journal, the paper, the world's best journal. Every, the researchers have a craze to publish a paper in Nature. So he was delivering a talk from USA yesterday. I was lucky to participate in that. It was organized by IIT Gandhinagar. So it many things about the oceanography. So while still there are many unexplored part, and that exploration, if possible, maybe something new, because always if it is more innovative and something new and it has some significance and it influences somehow or it contributes to the science, then it is easy to have that type of topic or to publish in a nature. So so there are still many areas in the oceanography. It has been estimated that more than 30,000 seamounts reaching more than 1,000 meters tall are found in the Pacific Ocean. You see, 30,000 mountains, sea mounts, in only one ocean, that is Pacific Ocean. You see, we have Uttarakhand, Himachal, and to Himalaya. It extends till Darjeeling, like Eastern Himalaya. So Garo, Khasi, Jaintia, and all these. There are many small hills, but we know how many hills are there. See, mountains are there. You see, only in the Pacific Ocean, there are 30,000 mountains. Approximately 800 are in the Atlantic Ocean, and an unknown number exists in the also Indian Ocean. You see how the sea mounts are features like pattern of a sea mount chain. These mountain chains, like we have mountain chains like Eastern Ghat, Western Ghat, Himalayan chain. It extends from like Western Himalaya to Eastern Himalaya to Darjeeling, like from if you see from Pamir North to or Hindu coast to uh, uh, like till the eastern range. Okay, so similarly here also the range, like we have Eastern Himalaya, Western Himalaya, sorry, Eastern Western Ghat and Eastern Ghats. So it's a range of mountains going. I mean, mountain range is there, and there is some cut between that, and still it extends. Like it's like similarly we have sea mountains, just like it's a chain. Okay, then we have abyssal plain, huge flat sediment covered areas of the deep ocean floor, and it covered in mud and the remains of tiny marine organisms. Occurs in depth of 6,500 meters below the sea level or lower. Sometimes these are abyssal plains, mostly the flat and huge land area. I mean landmass area mostly, where we can tell this in landmass. It's like plateau. Sorry, it's a plain, a valley area, like a valley area. After a hill mountain, there is a valley. It's all the populations mostly in the mountain area are residing within a valley side. So similarly, that is there in the sea, it is the abyssal plain. And mid-oceanic ridge, underwater mountain ranges formed by the plate tectonics. Rising magma between the plates and creates the ridge. Then we have Rift Valley, a lowland in the ground caused the seafloor spreading apart. So hydrothermal bands were discovered in Rift Valleys. This, when there is a sea floor spreading, concept of sea floor spreading, Harris was giving the concept of sea floor ready. Mostly this is also creation of the Rift Valley, different types of valleys as you have seen in the pictures. Okay, and these are you have to remember all these features and different types of topography and land formations, and then we will deal other parts of like why ocean is important for us to study. And volcanic islands. It's an island that was made from volcanoes erupting from the ocean floor. An island is a solitary mountain formed by volcanic activity. Lava erupting from the sea floor builds up on the seabed over thousands or even millions of years. The lava cools rapidly as it reaches the ocean water and forms solid rock. This becomes volcanic outline. Each eruption of this seafloor volcanic builds up the volcano a little bit higher until one day the eruption have built the top of the undersea mountains so high that is the rise above the ocean surface. Sometimes it depends. Like you know, the highest mountain peak in Japan is Mount Fuji, and that is a volcanic mountain. So you see, the volcanic mountain also very tall. I mean, it's going to have very tall, very high, and it's uh, like after this features of oceanic floor, ocean topography. Now we can go for the physical properties of the oceans. So seawater is a complex mixture of water and salts, the dissolved minerals, making of about 3.5% of seawater. Salinity is the proportion of the dissolved salts to pure water. It is usually expressed in terms of ppt, parts per thousand, or percentage. You see, some ocean, if it is no near like 25% salinity, that means out of 1000 grams, only 25 grams are salt. Okay, that means 1 liter of water, seawater, only 25 grams of salt. So this ocean salinity within the physical features, this ocean salinity is very, very important. We have also sea surface temperature issue. I will tell you in detail what is sea surface temperature issue, and this temperature fluctuations is a very bigger role in climate variability, different types of global climate phenomena. And this ocean salinity is defined as the ratio between the weight of the dissolved materials and the weight of the sample seawater. Okay. So generally, salinity is defined as the total amount of solid material in grams contained in 1 kilogram of seawater and expressed as parts per thousand. So salinity also means 25 grams of salt in 1000 grams of seawater. This way we are defining salinity. So ocean salinity affects the marine organism and plant community. Very, very important things. How salinity affects the different types of marine organisms. Different types of sea aquatic life features. With different types of fish based on the like salinity of a area. Particular fish is available only particular area. That fish you can't find in other areas. It depends upon ocean temperature, ocean water, and sea surface temperature, upwelling, and also the how much saline is the seawater. Then within the physical properties like temperature, water density, pressure, waves, evaporations, and currents are affected by salinity. These physical properties like temperature, if some area is very saline, its temperature, water temperature will be affected. If it is very less saline, it will, it depends upon if it is more saline, how the temperature behaves, and if it is less saline, how the temperature behaves. So that means salinity also determines a particular ocean's temperature features, along with how much, other characteristics, radiations of the solar or sun is coming and how much they are observing. There are many other issues, but still, salinity is also one of the factors that affects the temperature. Then density, water density. Of course, it is density of water will be influenced or affected by salinity. Then pressure, pressure in the water, and then waves, saline water. If there is more saline water, whether waves can propagate and can damage, and how the speed, I mean different types of the waves propagation, length, and all these also features are also affected by the salinity. Then evaporations, a saline area evaporations, how much evaporates, uh, ocean having more saline water and ocean having very less saline water, and also currents. Obviously, these physical properties are influenced by the salinity. So, if we will talk about the physical features, this temperature distributions ocean-wise, there is a clear distributions of ocean temperature, salinity also, how salinity has been distributed in different oceans around the globe, and all these features are there. But since it is only one lecture, after the topographic features, I will go more the special features of ocean dynamics, which is very important to understand the weather, climate variability, and the all these features in the landmass, whatever happening there. I mean, we have the rainfall and all these features that happens because of this many important features of uh, land and ocean interaction also, like land, ocean, and atmosphere interactions. It's very important features. So I will talk more about the dynamics part in the after this ocean features and topography of the oceans. See, the surprisingly, the salinity in the ocean. Okay, so surprisingly, the salinity in the oceans is relatively constant. And although many billion tons of salts are added annually, salts are used in making hard parts of the ocean creatures, cells, absorbed by marine plants as nutrients, and most salts are precipitated out as sediment. And overall, the oceans naturally tend to chemically mass balance themselves. So research from the oceans and seawater are like sea salt, we have magnesiums, bromine, or different types of like salts are coming from the oceans. There is a very and if you are talking about ocean deposits, uh, resources, mineral resources from the oceans, then maybe we need for ocean deposits itself we can have a separate class, and maybe at least 20 to 25 class will be somehow justified for the oceanography to cover all this area. Even for salinity, it itself a one class, and for temperature distributions, how temperature is behaving in a sea and ocean, that is also totally maybe one or two class. So just I tried myself to cover all this after the landforms to all these features, and then we can go like other features also. Like you see, within the surface mixing zone is the warmest and saltiest near bottom of the zone. Like when you are coming from the surface to the sea, how this salinity differs. You know how this salinity differs. You can have a clear picture when you enter, like a river coming to the sea, and within that, when river where meets to the sea, that part may be salinity is very less. It's very obvious, and so that area is also very good for the fencing ground. Okay, where huge great rivers are meeting to the ocean because of this sweet water. So many different types of fields, fishing grounds are there, where the river waters mix into the sea. So these are the very slowly you can go. If you go, 80% of the salts are there in the deep zone mostly, and in transition zone only 18%, and surface mid zone only 2% salinity is there. Okay, so this is the salinity. It varies from when you enter from the land to the ocean. Mostly salinity is there in the deep zone. Okay. Then we have ocean tides. Ocean tides refers to the cyclic rise and fall of the sea water. And the origin of tides in the oceans is primarily concerned with the gravitational force of the sun and the moon. When sun and moon I mean, that has like we have nip tide, spring tide. There are all different types of tides are there. So how it happens and how the tides are there occurring. There are also, you know, different theories also you can see. Okay, so the moon is the primary factor controlling the temporal rhythm and height of the tides, and along with the Earth's rotation and the moon's, it's Earth and moon's, uh, when the close, when it is closer, then the sea water also going up, I mean more height is there. So all this spring tide and the nip tide and all these type of tides, I think this is the basic features you know. But still, I just add that, like what are the tides and how it forms. The moon procedures two tidal belongs somewhere in the earth through the effects of gravitational attractions. Okay, and the height of these tidal bundles is controlled by the moon's gravitational force, basically, and the earth's gravity pulling the water back towards the earth. And at the location of the Earth closest to the moon, seawater is drawn towards the moon because of the greater strength of the gravitational attraction. And the opposite of the side of the Earth, another tidal bundle is produced away from the moon. Okay. However, this bulge is due to the fact that at this point on the Earth, the force of the moon's gravity is at its weakest. Considering these informations, any given point of Earth's surface should experience two tidal crests and two tidal troughs during each tidal period. That's why that 26 minutes and 52 minutes difference, like 12 hours, 26 minutes, or 24 hours, 52 minutes, that, when another tide will come and something, that type of explanations are already there. You can see tidal only that is there, how Earth and Moon, how this gravitational attraction comes and how the water is coming, and how this in this black part near the tidal bulge, So, like the tidal period, the timing of the tidal periods events is related to the Earth's rotation and the revolution of the Moon around the Earth. And if the Moon was stationary in a space, the tidal cycle would be 24 hours long. However, the moon is in the motion revolving around the earth. One revolution takes about 27 days and adds about, it's a detailed features like how the spring tides and nip tides are forming. And this revolution takes about 27 days and adds about 50 minutes to the tidal cycle. As a result, the tidal period is 24 hours and 50 minutes in length. And the second factor controlling tides on the Earth's surface is the sun's gravity. And the height of the average solar tide is about 50% the average lunar tides. And at certain times, during the moon's revolution around the Earth, the direction of its gravitational attraction is aligned with the sun. So during these times, the two tidal producing bodies act together to create the highest and lowest tides of the year. These spring tides occur every 14 to 15 days during the full moon and new moons because of this. And when the gravitational pull of the moon and sun are at the right angles to each other, the daily tidal variations on the earth are at their least. These events are called the neap tides, and they occur during the first and last quarter of the moon. Okay, so if you see this, like how the tidal waves are coming and how this affects the marine life, also you can see a different. It's totally a different also period. Like you can how the tidal affects the marine life, the coastal livelihood, and all these are also depends upon the like the tides, how it comes in a how the narrow and shallow is the shoreline, and how it affects. And I have seen an area also visited. Even you can find in the YouTube also like the coastal erosion and how the tides affects this village in the coastal belt of Orissa, and many villages already submerged in the water. Okay, this is very where the strong tides are coming. Slowly, the erosions are very high, and when the high tides are coming, and this time, Yas cyclone. This happens. That was the period. That time also there was it's a full moon day, so that also affected many areas because of the already very high tide and also with that adding that cyclone. This time it heights of these waves are so high. Okay, so these are basically about the ocean bottom topography and all these features, and these are boring part of the oceanography, if I can tell, because the landforms and different types of the uh, describing different types of features, different margins. These are those factual things you have to remember. You have to know, like these are the landforms, different types of you know topography of ocean basins. So when I mean, these ocean currents and the dynamics of oceans is very, very important. That is the real that governs the socio-economic issues of a region, of a country. Okay. For example, you can see El Nino and La Nina, how severely it affects also our country, India. Sometimes it's so drought, sometimes so flooded, very severe drought. So this is also affected by the because of ocean warming, and that develops like ENSO, El Nino, La Nina, and IOD, Indian Ocean Dipole, ENSO Modoki, Langano Nina, and California subtropical dipoles. So there are many, different types of features and variabilities because of ocean warming, and this ocean currents plays a major role also. So that is the next class. Just after 5 minutes break, I will just start the next class. Just give me 5 minutes. So this is the first class, and I can tell this is one of the class where you have to remember these features. Like what are the just know the different types of shapes and different types of ocean characteristics, features within oceans, and different types of land forms within the ocean, whether it is starting from the continental margin to a vessel plan to ocean plains. These are the also you can see this continent wise. Specific ocean, Atlantic Ocean, Indian Ocean, continent wise, also these type of features are clearly distinguished. And you can find a very good book for that, like Savinder Singh, Physical Geography. Savinder Singh, Physical Geography, read that oceanography part. It's very well also, though it's very precise one. You can read, if you read carefully all this Savinder Singh Physical Geography book, then you will find very clearly he has defined he has written the oceanography part there. So with that, this first part of the oceanography, like basically it is a topography of oceans, ocean topography is finished. Then in the next class, just give me 5 minutes, and I am coming back with the second part. Very interesting, and this is where my specialization area. I did my PhD on this part. I published many paper on this part, and still there are many. It's a very huge area of ocean currents and dynamics of oceans. Okay. With that, just taking 5 minutes break. Is that okay?
Yes, sir.
Yeah. So after this, I'm coming within 5 minutes. Next class. Okay.